Okay, so we discussed about this problem last time. We started chapter number 13. Okay, so let's move ahead, discuss about the spring force. You studied the spring force in statics as well. This is just a review. What is a spring force? The spring force depends upon how much the spring is stretched or compressed. So we have Fs is equals to Ks. K is the spring stiffness, Newton per meter. And S is how much the stretched or compressed length. Okay, now this is a point of confusion here. Okay, S is the amount of compressed length or the stretched length. That's not the total length. Keep that in mind. S is not the total length. So if the length initially was L naught and now after stretching the length is L, so S is L minus L naught, not the total length. Okay, so S is the stretch. But at the same time, in the book, sometimes they use S for the position as well. Okay, so now there comes the confusion. You might need to see the problem, and you might need to see that if in the problem there is a variable S, what does that S is referring to? Is that S is referred as a stretch, or is it referred as a position? Okay, so sometimes when you have the same variable for two different things, then it becomes a bit of point of confusion for the students. But keep that in mind that here when we are using S in the spring force equation, so this S is the stretch, and this is stretch means how much stretch, L minus L naught, not the total length. Okay, is this point clear? Okay, good. So let's see this problem. Okay, we have a smooth 2 kg collar. So this is a collar shown in the figure is stretched to a spring having a stiffness K equals to 3 Newton per meter and an unstretched length let me change the color to red, and an unstretched length of 0.75 meter. If the collar is released from rest at A, so this was the point A and the collar was at rest at A. This is a 2 kg collar. When it is released from rest, obviously 2 kg is quite a mass, so it is going to go down. Determine its acceleration and the normal force of the rod on the collar at an instant y equals to 1 meter. So when it reaches from A to C, okay, at this point we need to find acceleration of it and the normal force that the collar exerts. Obviously, the normal force is always perpendicular to the surface. So the force of the spring will be acting in this direction. The spring will be getting stretched, so it is going to push the collar or pull the collar towards itself. So, but the collar is on this vertical rod, so the normal force will be will be horizontal. Okay, like this. So that will be the normal force. So let's see the free body diagram. So you can see the free body diagram when the collar is at C. Okay, so when the collar is at C, we have this is the normal force of the collar on the rod. Okay, and then we have the weight of the collar acting downward. This is the weight, and we have a spring force acting. Okay, at some angle, obviously. The angle at which this spring force is acting is theta. Okay. So this is a free body diagram for this problem. First of all, is there anybody who don't understand the free body diagram? So please let me know. Is Okay, good. So since the body, why the normal force here? Well, look, the spring force is trying to pull the collar towards itself, but the collar will not move towards the spring, right? Because the collar is, there is a rod inside the collar which is holding the collar in its place. Okay, so if the spring force is there pulling the collar towards itself, then there is some another force which is pushing the collar back so that the collar does not move from its position. Okay, so that's why there is going to be a normal force which will be exerted. Is it clear? Okay, good. So since the body is moving in the downward direction, we can put y negative, y downward as positive and x as positive in this direction. There is acceleration in the downward direction. So this is how we can define our axis. You have gone through statics. It's our choice. How do we define the axis? There's no problem in it. Okay. Most of the time we avoid to negative signs. So we define the axis such that we don't have so many negative signs. Okay, so let's have a summation of forces in the x and y direction. Okay, so first of all, if the collar is moving down, so there is acceleration in the y direction. There is no movement in the x direction. Since there is no movement in the x direction, so ax will be 0. So summation of forces in the x direction will be 0, but the summation of forces in the y direction will not be 0. Why? Because there is motion in the y direction. Okay, so if you see over the x direction, we have the normal force in the x direction, and then we have the spring force in the opposite to the x direction. So it will be fs cos theta minus nc. Okay, so minus nc plus fs cos theta equals to 0. That will be the first equation. Okay, and then in the second equation, for summation fy equals to may. So summation fy will be what? So we have the weight acting downward. We'll consider it positive, as y downward is positive. And then we will have a component of fs which will be acting upward. Okay, so that will be considered as negative. So fs sine theta. So 19.62 minus fs sine theta equals to 2a. Okay, so these are the two equations. Before moving forward, do you understand how do we make these two equations? Is there any student who wants more clarification in how did we make the two equations? Good. So now we need to find A. This is our point, and we need to find NC. Okay, we can find A and the normal force very easily, but we need to first find what is Fs. Fs is the spring force. Now the Fs, this depends upon the stretch. How much is the stretch? Okay, so now it's actually a problem of mathematics here. We know that we have to solve this problem when y is equals to 1. So we know that y is 1. We know this is 0.75. So if we know this distance and if we know this distance, can we find this length? Yes, we can find by using the Pythagoras theorem. We can find this. Okay, so y square plus means 1 is square plus 0.75 is square, whole in the root will give you this length. But this length is not s. This length is the total length. We need to know what is the unstretched length. So I think it is written in the question what is the unstretched length. Yes, an unstretched length of 0.75. So whatever this length is, minus 0.75 will give you the s, which we are going to use in the formula for F is equals to Ks. Do you understand this point or not? Okay, so move here, see the solution, we find S. So S is basically y squared plus 0.75 is square under root minus 0.75 because S is the stretch, not the total length. So we can put the value of y directly, and we can find out, because we know what is k, then we know what is s, we will find what is fs. If we know fs, we just substitute fs here. Now theta, we also need theta, but we can find theta because it's a right angle triangle. Okay, so whatever the theta here, whatever the theta here, this will be the same theta we will have here. Okay, so this theta will be the same theta as we have here. We can find out this theta because we know this length, we know this length. This is a right angle triangle. In the second equation, why we put 2a? Okay, one student is asking that. Just a minute. Why we put 2a? Because it's MAY. What is the mass? Mass is 2 kg. This is 2 kg collar. Is clear? Okay. So that's it. We just substitute the values. We will find what is tan theta. We will find what is theta. Once we have theta, once we have fs, we can find what is nc. We can find what is acceleration. So that's the solution of the problem. Is there anything which anybody do not understand in the solution of the problem? You can ask. It's actually simple. There's nothing new into it. You already gone through this in the statics a lot. The only difference was that in the statics, there was no equation where the acceleration was, in all the equations, acceleration was zero. So summation fx was zero, summation fy was zero. Here, we will have some of the equations where ax and ay will not be zero. So that's the only difference. Otherwise, you have gone through all of this. Okay, so let's move ahead. This question is done. Okay, so there are different ways of dividing the problem. Like for example, if there is a curvilinear motion, you can what we can do is that you can divide the problem into x, y, z coordinates, and these are known as the rectangular coordinates. But there are other coordinate systems as well. You can divide the problem into other coordinates. Let's say we have a normal tangential coordinate system. So let's discuss if we solve the problem using normal tangential coordinate system. So what are the normal tangential coordinate systems? So let's have a look at it. Suppose that the path is like this. Suppose this is the path starting from O, particle is moving through the path like this. Then we can have two coordinates, one which is tangent to the motion of the particle all the time. So like for example, when the particle is here, so the tangent direction is this. So this is a tangent coordinate. And then normal to that, at 90 degree from that, but on the concave side, this is the concave side. On the concave side, okay, you have another coordinate, okay, which is the normal coordinate system, okay, and it will be at 90 degree from the tangent. Okay, so this will be the tangential and normal coordinate system. Any problem could be solved using both the methodologies. There is no problem, but sometimes the problem is solvable easily in one methodology compared to the other methodology. So we need to learn both the methodologies. Then it's the choice of the engineer to decide that which methodology is better for the kind of a problem he's facing. Okay, so now we don't have x, y, z directions, rather we have tangential and normal directions. Okay, so they look like this. Okay, now whenever we have a curvature, whenever it is a curved path, okay, so you will find that for a curvature, there is always going to be a radius. So there is always going to be a center of curvature. So let's say that the curvature is Let's say this part, for this part of the curvature, the center of curvature will be here. For this part of the curvature, center of curvature will be here. And corresponding to the center of curvature, there will always going to be a radius of curvature. So the radius of curvature as well as the center of curvature will keep on changing from point to point as the particle moves along the path. So when the path was in this part of the curve, the center of curvature and radius of curvature were in this direction. However, when it moves towards this path of the curve, then the center of curvature and the radius of curvature moved in the other direction. Why? Because always center of curvature and radius of curvature are in the concave direction. So these are the concave directions. So we have a radius of curvature and we have the center of curvature, and let's denote it by the symbol rho, which we normally use for density. But here we are going to define the radius of curvature by the Greek letter rho. Okay, so we have the velocity. Whenever we have the velocity of a body, so velocity is always considered as what's the direction of the velocity when a particle is moving along a certain path. It's always tangent to the path itself. So it is always considered to be in the tangential direction. So the velocity is equals to s dot ds by dt, and that's where does it point? It always point in the tangential direction over the path. Okay, so now what we can do is that we have velocity and we need to find acceleration. So what we do is that we differentiate velocity with respect to time. Now velocity is a combination of two things here. The magnitude and the direction. This is the magnitude, this is the direction of velocity. Okay, so if you differentiate this velocity with respect to acceleration, so now there could be change in the velocity with time, as well as there could be change in the direction with time. So if the change is in the magnitude with time, that's acceleration, v dot. If there is change, the dot position is wrong here. The dot should be here on ut. If there is change if there is change in the magnitude, if there's change in the direction, then this is ut dot. And this is known as the normal direction. So we have two components of acceleration. We have tangential component of acceleration. We have normal component of acceleration. Tangential component of acceleration means change in the magnitude of the velocity. This is the regular acceleration that we know. But the normal component of acceleration means change in the direction of the velocity. So we can write it like this: A is equals to v dot ut plus v square upon rho un. Now how do we come up with this formula v square upon rho? We don't need to go into that derivation. Okay, so if we want to find what is the formula for the normal component of acceleration, it's v square upon rho. Okay, how do we came up with this formula? There's a small derivation in the book. If you want, you can go through with that derivation. Anyways, that is not important here for the point of view of application. Okay, so we have two components of acceleration. One component of acceleration in the tangential direction. Let's say we call this AT. Okay, so this is AT. It will be in the tangential direction. Okay, and this is basically what regular differential of velocity with respect to time. Okay, then we have another component of acceleration, which is an, and it will have the normal direction. So it's a normal component of acceleration in the normal direction. Okay, and what will be the magnitude of this normal acceleration? It's v square upon rho. Okay. So we have two components of acceleration here. So there are two components of the acceleration vector. A is equals to at ut plus an un. And if we have at and an, then we can find out the overall magnitude of the acceleration as at square plus an square whole under root, where an is v square upon rho, at is v dot. Okay, now there are some special cases we can look into that. For example, if a particle is moving along a straight line. So if the particle is moving along the straight line, that means v square upon rho. Rho is the radius of curvature, but for a straight line, the radius of curvature goes infinity. So that means an will be 0. And that's understandable. If the particle is moving in a straight line, that means there is no curvature. So if there is no curvature, that means the normal component is 0. So we have the total acceleration, only the tangential component. Okay. Then let's see the second case. Suppose a particle moves along a curve at a constant speed. So particle is moving at a constant speed. Constant speed means the velocity is not changing. So it's understood that there is no acceleration. But this is the tangential component we are talking about. But maybe the particle is moving along a curve here. Since the particle is moving along the curve, the magnitude of velocity is not changing, but the direction of velocity is changing. And velocity depends upon magnitude and direction. If one of them is changing, that means the velocity is changing. Okay, so now in that case, at will be 0. The tangential component of acceleration is 0, but the normal component will still be there because it is moving along a curve. So curve means there is a curvature, so the direction is changing all the time. So normal component represents the time rate of change of direction of the velocity. So let's have another thing. Suppose when we have the tangential component of acceleration, then that tangential component of acceleration can be used as a regular constant acceleration if it is constant, and we can use it in the equations that we developed before, like equations 7, 8, 9. So those equations are for the constant acceleration. So if tangential component is constant, we can use that tangential component in one of the three equations if you want. The fourth thing is that suppose if we know the path of the motion of the particle as y as a function of fx, then we can find out the radius of curvature using this formula. Rho equals to 1 plus dy by dx square whole power 3 by 2 divided by d square y by dx square absolute. So anyways, this formula will be provided to you in the exam if needed. But this formula can only be used if you know the motion, if you know the path of curvature as well. So it's y as a function of x. If you know that, then you can use this formula. Okay, so anybody has any questions so far? Okay, so let's move ahead. Okay, we discussed one thing that in the rectangular components, what do we have? We have x direction, y direction, z direction. So we have 3 dimensions. So what about here in the normal tangential coordinate system? We have normal, we have tangential, and we know that normal and tangential are at 90 degrees from each other, so they're perpendicular to each other. So these are the 2 axes, but there has to be a third axis as well. So what do we call that third axis? We call the third axis as the binomial axis. Okay, we call this third axis as the binomial axis. So it's written here, this is a binomial direction. Okay, so un is perpendicular to ut, but ub is perpendicular to both un and ut. So that's the binomial direction. Anyways, there aren't really much problems where we have to solve in the binomial direction. Okay, so let's have an example. The train engine at E has a speed of 20 meters per second and an acceleration of 14 meters per second square acting in the direction shown. So you can see here that we have a train engine. At this point E, the train engine has an acceleration given, and the angle at which this acceleration is acting is also provided. So, okay, so what is asked here in the problem? So asked is that find the rate of increase in the train's speed and the radius of curvature of the path. So first of all, what is asked? Find the rate of increase in train speed. Rate of increase in train speed. Rate of increase in train speed is what? It's actually the tangential. It's actually the tangential acceleration what they are asking about. Okay. So rate of increase in train speed will be the tangential acceleration. But they could have asked in the question like this, that find the tangential acceleration. But that would make the problem a bit easy for the students to understand. Dynamics is all about making things more complicated. Okay. So it's a rate of increase in the train's speed. So that's why you have to decode it yourself, what they are asking. So it's not AN. AN will be the rate of change in the train's direction. You got it? If it was a AN, if they was asking AN, then they will ask what is the rate of change in train's direction. But they're not asking AN, they're asking AT. That's the rate of increase in train's speed. Okay. What is the second thing which is asked? Well, find the radius of curvature of the path, which is rho. Okay. So since here in this problem, we have A already with us and we know the angle at which it is acting. Okay, so we can actually find AT and AN easily. Just AT will be here A cos 75. Okay, and AN will be A sine 75. So we have AN and AT directly available with us. But then if you know AN, you can find radius of curvature because AN is V squared upon rho. Since AN is V squared upon rho, and you know the velocity because it was mentioned that the train has a speed of 20 meters per second at this point E. So, and now you also know the normal acceleration, you can find out what is the radius of curvature. The problem is solved here. Is there anything that you do not understand in the solution of the problem? You can ask. Okay, so.
Doctor?
Yes.
Is it okay if I use the V squared over R?
V squared over R? Yes, it's okay.
Yeah.
Look, this is a symbol here, okay? So radius of curvature, if you put R, no problem in that. But only why we tend to use the same symbol which is being used in the book, because many times you need to see the problems in the book. Many times you need to solve the problems from the book. Many times the problems are given from the book in the exam. So just to remain consistent with the book, we use the symbols given in the book. Otherwise, you are free to use any other symbol if you want.
Okay, thank you.
Okay. So let's move ahead. Okay, equations of motion in the same way, like for example, when we were talking about the rectangular coordinate system, so we have summation fx equals to max, summation fy was equals to may, summation fz was maz. Now we are talking about the normal tangential coordinate system, so we'll have summation an will be equals to man, summation summation fn will be equals to man, summation ft, tangential coordinate will be equals to mat, and summation fb will be equals to mab, the binomial coordinate, normal coordinate, tangential coordinate. Okay, so let's see a problem here. Okay, at an instant when theta is 45 degree, The boy with a mass of 75 kg moves a speed of 6 meter per second, which is increasing at zero point 0.5 meter per second square. Okay, neglect his size and mass of the seat and chords. The seat is pin connected to the frame BC. Find horizontal and vertical reactions of the seat on the boy. Okay, so now before moving towards the solution of the problem, let's first understand the problem. Let's first see what is given in the problem, what is asked in the problem. Okay, so you see here, this is, I don't know what it is. Maybe it's a kind of a play game or something. All right. So a boy is sitting on a seat here, which is connected with a rod and connected over here, pin connected at point C. Okay. So this thing is moving. So this thing is moving like this. Okay. And this link has length of 10 meter. At this instant, theta is 45 degree. So they mentioned theta here. This is 45 degree. Okay. 45 degree. Allahu Akbar. Writing is very difficult. The boy with a mass of 75 kg. So this boy has a mass of 75 kg. Moves with a speed of 6 meter per second. So what is given? Velocity, right? So the velocity of the boy is right now given 6 meter per second. Okay. Which is increasing at 0.5 meter per second square. So what is given? It's given AT. Okay. This is dynamics. Everything is always complicated. So you need to decode the problem yourself. So what is given is that which is increasing at 0.5 meter per second square means the velocity rate of increase of velocity is given. It's AT. Okay. So AT is given as 0.5 meter per second square. We need to neglect the size and the mass of the seat and chords. The seat has been connected to the frame BC. Find the horizontal and vertical reactions of the seat on the boy. Obviously, the boy is seated, so there will be horizontal reaction. There will be, there will be vertical reaction. There will be horizontal reaction of the seat on the boy. So we need to find these reactions. So before moving towards the solution of the problem, first of all, do you understand the problem statement or not? Is there any student who has any problem in the solution of the problem? In the statement of the problem, solution, we are going to proceed now. Okay, good. So let me erase this. Okay. So the first thing is that we need to draw the free body diagram. Okay. So the free body diagram would be like this. Okay. Now have a look at it here. That this is the path. Let me try to draw the path here. So this is the path of the boy. Okay, this is the path of the boy. The boy is moving in this direction. So tangential direction would be like this. Okay, the normal to the tangential direction would be like this, because this is the this is the concave direction. Okay, so we will have the weight of the boy acting downward. Okay, and then you'll have the reaction forces, the vertical reaction Ry, horizontal reaction Rx. Don't worry about the direction of the reaction forces right now, because if your direction, your assumed direction is wrong, your answer will be negative. That's the only thing that will happen. Okay, so let's say that we are saying Ry is up and Rx is towards the positive x direction. Okay, so that's the free body diagram, and this makes 45 degree from here. Rx makes 45 degree from the normal. Why? Because this was connected here like this, and the theta was 45 here. So since theta was 45 here, so this Rx is going to make 45 degree with n. And if this makes 45 degree with n, then Rx and Ry, the total angle will be 90 degree between Rx and Ry. And if this is 45 degree, then this should also be 45 degree. Okay, and if we extend it here and we extend it here, this should also be 45 degree. So actually everything will be 45 degree from here. Okay, from n to Rx is 45 degree, but n and t are perpendicular to each other, so Rx and t would also be 45 degree. Then t and w would also be 45 degree. Okay, what happened? Okay, good. So do you understand the free body diagram? Is there anything in the free body diagram that you do not understood? Okay, but you know that we do not just have to make the free body diagram, we also need to make the kinetic diagram. So kinetic diagram will be what? You will have an acceleration in the normal direction, so it will be MAN, and you will have an acceleration in the tangential direction, it is MAT. This diagram, kinetic diagram, normally seems a very useless diagram. It is actually a useless diagram, but you need to draw it because it will carry marks. Okay, so let's move ahead. Okay, so now what do we need to do? We need to make the summation of forces in the normal direction and the summation of forces in the tangential direction. So summation Fn equals to Man, summation Ft equals to Mat. Okay, so let's discuss about the normal direction. Summation Fn equals to Man. So we will see about the forces here, but let's see about Man. So we have mass, we know the mass, right? We know the mass. And normal acceleration, we know the velocity. We know the velocity, and we know that this rod is 10 meter. So we know the rho, so we can find the normal acceleration. So we know m, we know an. So we know this term here totally. Okay, is it clear? Good. Okay, now let's discuss about the forces, summation of forces in the normal direction. Now there's something that you need to see. Look, all the angles are 45 degrees, so that's not a big issue. Even sine 45, cos 45 will give you the same answer. Okay, the problem is only to look at the direction of forces, negative or positive. Whether we have three forces here, Rx, Ry, and the weight. So let's see about that. So let's come here. Okay, how do we define n positive? If the n is moving towards the radius of curvature, if the force is moving towards the radius of curvature, towards the center of curvature, then it is positive. If it is moving away from the center of curvature, we can define it as negative. If tangential direction is very clear, where the direction is more moving, so we will consider t positive in this direction, okay, negative in the opposite direction, and positive in this direction, negative in the opposite direction. Now let me change the color so that we change it to blue color maybe. So let's see Rx. So Rx, we say that is in this direction, right? So we need to now divide Rx into T and N component. Okay. So if I divide, if I want to put Rx in the N component, what do you think? It would act in the positive N component or the negative N component. The component of Rx, if I take a projection of it on the normal direction, projection of Rx in the normal direction, so then it will be directed outward. So it will be negative. Yes, it will be negative because it will be directed outward. Okay, so Rx in the normal direction, it will be negative. What about Ry? Also, the projection of Ry, if I take it on the normal direction, on the normal axis, so it will again be like this. Negative. So you just remember that Rx, Ry both negative. What about the weight? The weight, if I take the projection in the normal direction on the normal axis, so that would be in the positive direction, right? So weight will have a projection in the positive direction. Rx and Ry will have a projection in the negative direction. Okay, so let's hold it here and go back there. See, Rx negative, Ry negative, weight positive. It's clear? Good. Okay, Shahad Ali Khan, this is not clear. Can you repeat it? Let me repeat it again. Okay. If you have any specific thing which is not clear, you can ask me directly. Okay. So that will be better so that I know that what is not clear. Otherwise, I can repeat the whole thing if you want. Okay. So let's again repeat it. So you see here, we have Rx, Ry, and W, and we need to define the positive and negative directions. So the boy is moving in this direction. Okay. So tendential is positive in this direction here. Okay. And the normal should be considered positive when it is towards the center of curvature. So normal is positive towards O, center of curvature. Okay. So positive for N is this, positive for T is this. Is this thing clear so far? Okay. So now let's see each and every component. We have Rx. Okay, Rx was in the positive x direction. If we want to make a component of Rx, if we want to take a projection of it in the normal direction, so what do you think? The projection in the normal direction will be in the positive n direction or the negative n direction? See the arrow. If we take the projection of it, it will be in the negative. Okay, now let's say if you want to take a projection of Ry on the normal direction, what do you think? The projection of Ry on the normal direction will be in the positive n direction, negative n direction. Okay, so it will be negative. And let's talk about W. If you want to take the projection of W in the normal direction, would it be the positive n direction or the negative n direction? It will be positive. This is what I was saying. Okay, so let's go to this equation. See here, Rx negative, Ry negative, W positive. Okay. So is it clear so far? Before moving ahead, I need to know if this thing is clear or not. Okay, so let's move ahead. Now we have, so in this equation, Rx and Ry are unknown. Now we can make the summation in the for the forces in the tangential directions equals to MAT. Let's go back. Okay, so Rx, projection of Rx in the tangential direction. What do you think? Positive, negative? Projection of Rx in the tangential direction. Negative. Sure, negative. See the arrow? You want to make the projection in the tangential direction, it would be negative. Okay. Projection of Ry in the tangential direction. Well, a lot of imagination. Yes, positive. True. Projection of W in the tangential direction. Negative. W negative, Rx negative, but Ry positive. Let's see. W negative, Rx negative, Ry positive. Okay. So this equals to MAT. We know AT because I mentioned you before that in this question AT is given. Okay. And we know the mass. So again, we have two equations, everything known except Rx and Ry. So we have two equations, two unknown. Now it's no more a problem of dynamics, a problem of mathematics. So you can solve it. You can find what is Rx, you can find what is Ry. And that was actually needed. Can we draw Rx in the opposite direction? True, you can do that. But just remember that the direction that you're going to choose of Rx or Ry, then your equations should be corresponding with the direction that you choose. So if I see the solution of your problem, I'm going to see what diagram did you make, and because rx and y are y direction, you are the one you can choose yourself initially. Okay, so but then your equations should be in correspondence. I mean, it should be in agreement with the diagram that you made, and that will be correct, no problem in it if you do it like this. Okay, is it clear? Okay, so is there anything in the solution of the problem which any of the student do not understand? You can ask. An always positive. Yeah, an is always positive. True. Why an is always positive? Because look at the unit of an. It's the magnitude of an is v square upon rho. V is the velocity. Velocity maximum can be zero. Well, it cannot be negative. Okay. So, and rho is the radius of curvature, so can maximum be zero, but cannot be negative. Yeah, true. So an will always be positive. Okay, so if everything is clear, then I will rub my screen whatever I wrote. Okay, so far. Okay, so let me rub it. Yes, it's always towards the center. So you can solve the problem, you get Rx, Ry, and the problem is solved. This is a problem for the binomial direction. You can see the problem yourself. There was just a regular derivation of it. Let's move towards this problem. Example 13. Okay, the 60 kg skateboarder is in figure 1315A, coasts down the circular track. If he starts from rest when theta is 0, determine the magnitude of the normal reaction the track exerts on him when theta is 60 degree. Neglect his size for the calculation. Okay. Before moving towards the solution, let's first try to understand the problem statement thoroughly. Okay, so we have, this is a case. So we have the 60 kg skateboarder. Okay, in the figure, he goes down the circular track. So this is the circular track where the skateboarder moves. If he start from rest when theta is 0, so he start from this point at rest when theta is 0. This is the theta, how it's defined as. Determine the magnitude of the normal reaction the track exerts on him. Obviously, when he's moving through over the track will exert a normal reaction on him. Okay. When theta is 60 degrees. So when theta is 60 degrees, we need to find what is this normal reaction. Okay, good. Do you understand the problem statement? Okay. Now let's see how do we solve the problem. Let's see how do we move for the solution of the problem. Actually, this is a very complicated problem, and I will tell you what's the complication in the problem. I'm going to tell you that. But let's proceed with the solution. Okay, the first thing is that what we do is that we draw the free body diagram. Okay, so we come here. This is the skateboarder. Our good man, he is doing the skateboarding. Okay, so have a look at it with the free body diagram. We'll have the normal force of the track exerted over him. Then we'll have the weight, which is acting downward. Okay, and the weight will be acting at angle theta. You do understand how this becomes angle theta. This is actually not dynamics, this is mathematics. If this was theta, how come this becomes theta? Can you understand that? Okay, I hope you understand that. uh, Let me still, because most of the time this is a point that students don't understand very well. Okay, so let me explain it the way I explain it. I I think it's okay. What you're saying is also okay, but let me explain it with the way I explain things. Okay, so uh, this line and this line are making an angle theta. Okay, so if the two lines make an angle theta, then both of them, their perpendicular will also make theta. Okay, so this line and this line is making theta. So perpendicular of this of horizontal is the vertical. So that is where the W is acting. Okay, and the perpendicular for this is the normal direction line. This is the normal direction line. Perpendicular for this will be the tangential line. Tangential line. Okay. So this, oh sorry, I didn't make the straight line. So this will also make theta. If the two lines are making theta, their perpendiculars will also make theta. So this and this was making theta. So n perpendicular of n is t, perpendicular of horizontal line is vertical line. So vertical and t will also make theta. This is how I understand the problem, but you can have different understanding as well, and that might be correct as well. This is mathematics. There are different ways. Is it clear? Okay. So, so okay, so let's see the free body diagram. Okay, so you see here we have the tangential direction, which should be the direction of the motion of our skateboarder. Okay, obviously the track is like this. The track is like this. So this will be the normal direction. So that will be the positive n direction. That will be the positive t direction. Okay, and this will be the normal reaction of the track over the skateboarder, and there will be the weight, and the weight will be acting at angle theta. So that's the free body diagram. Do you understand the free body diagram? Is there anything in the free body diagram which any student do not understand? You can ask. Okay, good. So now if things are clear here, so let's try to make the summation of forces. So summation of forces in the normal direction, summation of forces in the tangential direction. Okay. So if you see in the what forces, there are only two forces involved. One is the normal reaction, and other is the weight. Weight will have a component in the tangential direction as well as the component in the normal direction. But this force, normal reaction, will have no component in the tangential direction. It is actually acting in the normal direction. Okay, so let's have the equation. So you see here, um, in the normal direction. So in so let's talk about the tangential direction. Tangential direction. So you will have a component of the weight in the tangential direction, and that's it. There is nothing else. Component of weight in the tangential direction. It will be 60 into 9.81 cos theta. 60 into 9.81 cos theta equals to MAT, where M is 60 and AT is 80. Okay. Is this equation clear or not? Before moving forward, I need to know, is this equation clear or not? Okay, good. Let's move ahead. Let's see the other equation. The other equation is basically what? It will be in the normal direction. In the normal direction, we have two forces, one ns and one component of the weight in the normal direction. Ns will be in the positive direction, negative direction. Positive, right. And what about the component of the weight in the normal direction? Would it be in the positive direction? Negative. It should be negative. True. It should be negative. Okay. So it will be ns minus 16 to 9.81 sine theta equals to m and an. An is basically what? V square upon rho. Rho is very clear because it's a circular track. So center radius of curvature will be 4 meters. So it should be 4. Okay. So this becomes this equation. Now I need to know, do you understand how we made this equation? Is there anyone who do not understand the solution? Is there anyone who do not understand how do we make the equilibrium of forces in the normal and tangential direction? How do we make these two equations? Is there anyone who do not understand that? Okay, so let's move ahead. Now what do we want? We want to determine the magnitude of normal reaction. So normal reaction is there in, what happened? Yes, so we want normal reaction. Normal reaction is there in this equation. But in this equation, there is no normal reaction. So it's kind of a useless equation for us. We do not want it anything else. We just wanted the normal reaction. So it's here in this equation. So this equation is useful for us. We have theta. It's mentioned here that in the question it's mentioned that we want to solve it for theta equals to 60 degree. So no problem here. We know theta. Okay, so theta is known. Do we know the velocity? There's the problem. You see here, if he starts from rest when theta is 0, we know the velocity when theta is 0, but we don't know the velocity when theta is 60 degree. So we cannot put the velocity here. We don't know the velocity when theta is 60 degree. How do we find that velocity? This is an issue now. Now we need to have an equation where we can relate velocity with theta. We have not studied any relationship where we can relate velocity with theta. I mean, when the theta is 0, velocity is 0. When the theta is 60, the velocity is, we need to find that. That's the problem. So that's why I told this is not an easy problem. So what approach are we going to use? So look here, we have another equation here. We have AT as a function of theta. We have AT as a function of theta, okay? So we can use this equation in V dV equals to AT ds. V dV equals to ADS, okay? If we want to use this equation here, now just once again, so we have one equation where AT is a function of theta. So we get AT equals to 9.81 cos theta. Now we can use this equation V dV equals to AT ds. We can put AT as a function of theta. Okay, ds is the distance, but we know this is a circular track. So circular track, for circular track, S is equals to R theta. So ds is equals to R d theta. So we can put, instead of ds, we can put here R d theta, where R is 4. Okay, so now we can have an equation where when the velocity is 0, when the theta is 0, velocity is 0. When the theta is 60, we can integrate it to find what would be the velocity. Do you see the problem here? Till here it was okay. But we wanted to know the velocity when theta is 60. We know the velocity when theta is 0. How to find the velocity when theta is 60? We need a relationship which can relate velocity with theta. So how to find that relationship? So first we develop a relationship where we have AT linked with theta. Then we can put it in VdV equals to ATDS to find out what could be the relationship of velocity with theta. And then we can substitute the limits and find out what will be the velocity when theta is 60 degree. Now, once you have the velocity when theta is 60 degree, you can just substitute it here and you will find what is the normal reaction of the track. Is this thing clear or not? This was a difficult question because of the input that we have and how to utilize it. Is there anyone who do not understand? You can ask. Okay, so it seems clear to everybody. So just of that. Okay, good. That's it. So all other slides, go through it yourself. And chapter number 13 is done. Next week, inshallah, we're going to start chapter number 14. So if anybody want to ask anything, you can ask. Otherwise, we are actually done for today. So this is the 4th week. Okay, 2 weeks we took for chapter number 12. 2 weeks we took for chapter number 13. Then 2 weeks we will take for chapter 14. 2 weeks for chapter 15. 1 for chapter 16. 2 weeks for chapter 17. We have a lot of weeks left. Anyways, so if anybody has anything to ask, you can ask. Otherwise, if you want to leave, you can leave. Class leader, I will be waiting your response as soon as possible. Okay. Thank you. That's it for today.